All right, pre-calculus, here we go. Page 2 of 6.1 coming your way for this Monday. Ed puzzle assignment. All right, so another way to measure angles. All right, so measuring angles, all about angles. So in the past, we have measured angles by degrees. Okay, so in geometry, you got this, I'm just going to draw this angle over here, and we're going to put it in standard position. So this angle right here, I'm going to call it theta. Very common way to name an angle is with theta. So theta is just a Greek letter, Theta. Okay, lots of the times we use theta for angles. All right, so that's an angle right there, starting at sort of 0 degrees and heading up to, this is 90 degrees. So this looks about 45 degrees. Okay, so maybe I've drawn a 45-degree angle there. Okay, so that should make sense. That's just how wide it is in terms of degrees. All right, so that measures at the central angle. And that's with the origin being the vertex. Another way to measure angles is in radians. All right, and radians are a way to measure the distance around the edge of the circle. So right here, if I wanted to look at this distance, what did this 45-degree kind of span on this unit circle? And so the radians is going to be measuring this distance right here. It's based on the unit circle. So what is the unit circle? Well, this word unit is pivotal. The unit just means that it's always going to have a radius of 1. Okay? If we're looking at this unit circle right here, that means from center to side, this would be 0.10. At degree 0 would be the 0.10. At degree 90, this would be 0.1. Over here, this 180, that would be negative 1, 0. And then 3/4 of the way at 270, you'd have the 0.0, negative 1. That's your unit circle, and we're going to work with that a ton starting right about now. All right, so if we wanted to look at this angle in degrees right here, and this radian measure, which is what I've indicated, radian, then we're just looking at a fraction of this full rotation, and this full rotation here would be the full circumference of the circle. So C stands for circumference, and the formula for circumference is 2 pi r, and we're keeping our radius at 1 because this is based, radians are defined off the unit circle. So what is the distance along the unit circle? In terms of the central angle, sure, 360. But on the circumference along it, that would be 2 pi r. So 2 pi 1 or just 2 pi. Okay, so one complete revolution is 360 degrees. So, right here, this is 0 or 360. All right, well, that's looking at the central angle, but if we look at the perimeter, the circumference, one full rotation on the unit circle is 2 pi radians. So this point here is 0 degrees or 360 degrees, but in radians, we would call this 0 radians or 2 pi radians. 0 at the start, 2 pi at the finish if you were rotating. All right, so to convert, we're going to use this fact that 2 pi over 360 is going to be our conversion factor. So, for example, when you are converting, feet to miles, you use these dimensional analysis type fractions to get things to cancel out. The same type thing is going to happen here. We're going to use this pi over 180 when we convert from degrees to radians. This is our conversion factor. That's going to come into play real soon here. All right. So let's look at some equivalencies or some conversions. If we do half a revolution, that is 180 in terms of degrees. If we think about it in radians, that's pi. So we are going to begin transitioning from thinking of 180 degrees here as 180 degrees. We're going to start thinking of it as pi. All right. 1/6 of a revolution is 1/6 of 360. Okay, and that's 60 degrees. And if we thought of it in radians, that would be pi over 3. Another very common radian measure we're going to use is going to be that 60 degrees is pi over 3. Why is this going to be common? Just a flash from geometry. This is one of the angles in a special right triangle. Okay, special right triangle. If you recall, the unit circle is built off these special right triangles, and one of them was 30 degrees, 60 degrees, 90 degrees, if you recall. This side would be 1. We'll get into all this. Don't worry, this side was root 3, and this was 2. So we're going to be dealing with 60 degrees a lot because it's involved in the special right triangle. All right, 5/12 of a revolution is 5/12 of 360. So that's 150. If you did 5/12 of 2 pi, you're looking at cancel. You're looking at 5 pi over 6. Okay, so we've got that 5 pi over 6 is an equivalency to 150 degrees. We will be looking at this a lot as well as we move forward with this section. Okay, convert to radians. So when we convert to radians, from degrees to radians, we use pi over 180 as our conversion factor. So pi over 180, pi over 180, pi over 180. We're going to leave our answers in terms of pi, so we're not going to be taking this decimal, we're just going to be canceling. So 45 goes into 180, pi over 4 times. This is also a very common one we are going to use because this is from another special right triangle. And this is how we're going to build our unit circle. They're going to be built by 30s, 60s, 90s, and this special right here, 45, if you remember. I'm just showing you a little preview. If you have 45 degrees here, this is 1, 1, root 2. So you are going to see this pi over 4 very often. Okay, so if we're back up here, instead of calling this a 45 degree, we're going to be calling this a pi over 4 in radians. All right. Just some other ones just to practice. If you canceled here, you would want to find something that divides into both. I believe 15 divides into both of these. So I'm just dividing by 15 here. And this comes out to it. When you cancel all of this out, 15 goes into there. 7 pi over 12. All right, and then same thing here. I believe I can divide by 15 here also. And I get negative 11 pi over 12. Okay, so the next thing we're going to do is we're going to convert to degrees. So here we use the conversion factor of pi over 180. Here we're going to use 180 over pi. All right, and so how do you remember which one? I was just usually the radians, when you're given a radian, it will usually have a pi in it. Sometimes it doesn't. So what you can note here is there's the lack of the degree symbol. All of them had a degree symbol. And so you know their degrees, so you kind of want to get that pi into the problem. So you want pi in the numerator. Here, you're going to degrees, you want the pi out of the problem. So, you got the 180 over pi. 180 over pi. So you just have to pick the appropriate conversion factor to get what you need for what's being asked of you. All right, so the pi's cancel. 3 goes into 180 60 times. This is a 120 degree angle. We will use this one quite a bit too. We'll talk more about that later. Pi's cancel here, cancel, and then this is a negative 90 degree. Okay, cancel. We saw that went 15. This is a 75 degree angle. Okay, and then this one you would just basically use your TI. You'd have to go to your TI. Nothing cancels. You would just do 1.524 times 180 divided by pi. So TI active here, this is 87.32. Okay, so if you look up here as we're developing our unit circle, this would be your 0 to pi. This 90 degrees. You're going to start beginning to think of it as pi over 2. If I just did 90 times pi over 180, 90 would go into that 180 2 times. And then down here, this 270 will be 3 pi over 2. Okay, you would have your times pi over 180, and 90 would go into 273 times, and it would go into 180 twice. So just a little preview there of the unit circle. Last thing, let's do some coterminal angles. We've done this before. Now we're just going to do it in radians. But we're still going to just same process. We're going to add and subtract a full rotation, but this time it's going to be 2 pi. So find two angles that are coterminal with 2 pi over 3. So, before, you're going to know where 2 pi over 3 is before long, just by hearing 2 pi over 3. But, since we're just getting used to this, let's see what 2 pi over 3 is. Well, we did it right up here. That you would be going 180 over pi, cancel, that's 60. So this is a 120 degree angle. So we're going to start at standard position, and we're going to go to 120 degrees. So we're past the 90 degree mark, but not quite at 180. So this is a 2 pi over 3 angle. All right, so find two angles that are coterminal with it. Well, we could just start in standard position and then loop-de-loop around and then just land there. So what did I do? I did 2 pi, right? I did one rotation. I did one full rotation and then went 2 pi over 3 more. So you can write that as 2 pi over 3 plus 2 pi. Even though I started with the first rotation and then added on what was given, just as a general rule, you can add and subtract a full circle. All right, so then just common denominator of 3, so that's 6 pi. So this is 8 pi over 3. Coterminal with 2 pi over 3. They start and stop at the same one, just makes another rotation. All right, let's do another one, and then we'll call it a day. 2 pi over 3. Go this, this way. 2 pi over 3. I could go in a negative direction, right, and land at the same place. I could go this direction, okay, in a negative direction. This was in a positive direction, but just another rotation. So what is happening here is you've basically got this full circle less, we didn't make it all the way around in the negative direction. We were stopped by this 2 pi over 3. So how do we write that? That's just 2 pi over 3 minus 2 pi. Okay, so 2 pi over 3 minus 6 pi over 3. And this would be a negative 4 pi over 3 angle. Okay, you would write negative 4 pi over 3. Those are coterminal. And this is 8 pi over 3. Okay, I hope that made sense, and we will pick up where we left off here in class when I see you guys either in live or on the Google Meet. All right, take care. See ya.